seems no one quite understands physics, and it seems I'm not alone in that sentiment. It's been called the poetry of the universe, the stress that never ends, the questions at the heart of human nature, that weird subject that makes men bald, the mind of God. Why you shouldn't ram your car into a wall at 80 kilometers an hour, but maybe if you do it right? However, physics really isn't that complicated. You know why? Because this is the formula that all physics come from. Get it? Formula? If this happens, then this will happen because this. Wait a hecking second! This is literally what we learned in elementary school! I'm not even joking. If I jump off a mountain at the speed of light, I'll likely splat on the ground because, well, that's a lot of newtons. So yeah, really don't let physics scare you. It's genuinely not that hard. Wait, why is there still more of the video? Well, I may have forgotten to mention that physics is also one of the most, if not the most, diverse and complicated fields of study humanity has ever set its sights on. But please, stay with me, and I think you'll find that physics, while mind-bending, is also full of beautiful simplicity hidden underneath a fog of equations it loves to ask. Throughout my, and I'm sure your many educational years, most subjects started at ground level. You can't do algebra without 2 plus 2. However, when it comes to physics, looking at the incomprehensibly big may actually help us understand the deceptively complicated world of the small. When I said big, by the way, I meant it. Wait, is that the entire universe? Yep. Okay, whoa, that's a lot, but also it's, a ball? Well, probably. When physicists look at the universe, because of how huge it is, it's way easier to conceptualize it as such. This is a thing physicists do a lot, by the way. When things are too vast to make sense of, they tend to simplify the impossibly complex into something understandable, yet still theoretically accurate. In fact, physicists like to play with the rules of what seems accurate and what seems totally new and out there. I mean, take Einstein. In his theory of relativity, our traditional position versus time graphs were literally flipped on their heads to explain how time travel and space position are all related with speed. And you know what? It works. Physicists are the best at coming up with problems we never knew existed to find solutions to questions no one ever thought to ask. But back to the entire hecking universe, how did this even happen? Now, there are many philosophical and religious-based reasonings many have come up with throughout all of humanity. I myself am subject to personal beliefs. But on a physical level, whether you think this all happened on accident or on purpose, how exactly did this happen? Well, there are many schools of thought. Okay, I know I just said that, but leave me alone. People used to think the sun orbited us, okay? There are a lot of theories about everything. And that's what they are, by the way, theories. We can't prove without a doubt the Big Bang happened, and yet it's been taught to us from such a young age that it is this 1,000,000% true event of how it all began. What is the Big Bang, by the way? Okay, well, friggin' stop living under a rock. In 1927, Georges Lemaitre proposed that the universe began from a single infinitely dense point that rapidly expanded into the universe we know today. And when I say rapidly expanded, I mean rapidly. Interestingly, the Big Bang was much less of a bang and more of a grand escalation. I know I said this technically isn't proven, however, there is a lot of evidence to prove this theory that caught traction and is why it's widely regarded today to be true. The universe today is still expanding. Who would have thought such a grand universe could be explained by, well, Big Bang Boom the universe? Now, funny enough, as we zoom in, things get more complicated. So what exactly makes up this universe? So here's the weird part. Most of space, the entire universe, is made of nothing. And I don't mean no planets or stars or asteroids. I mean like literally nothing. And yet that nothing may be full of something. Confused yet? Well, there's this theory that the empty space in the universe is composed of what is known as dark matter. Get it? 'Cause it's dark? Okay. Well, okay, why do we think there's anything there at all? Well, astrophysicists can actually detect gravitational changes and light bending that simply don't make sense without the influence of some form of matter. For instance, why hasn't the universe just blown itself apart if it's always expanding? Well, some speculate dark matter holds the universe together. As matter, it would have gravity too, and since there would be so much of it, the universe ain't going nowhere. Or at least not enough to self-destruct. Okay, I'm bored. What else is around here? Well, all of this. Holy crap! Yeah, so turns out there are countless galaxies out there. Not all of them look like this, by the way, though. Some look like spirals, while others look like blobs, or maybe not even a galaxy at all. Another fun fact, by the way, humans love naming stuff after milk. I mean, come on. Milky Way? Galactic? Listen, I'm not a conspiracy theorist, but there's gotta be something more to that. But how did all of this order come from such chaos? Alright, so back to the Big Bang. Wait, no, before that. There! This is the whole universe. Ain't it cute? So notice how some spots are denser than others? May not seem like it, but it's a big deal. When it does that, those denser spots are what will compress and form star clusters and galaxies, which in turn form galaxy clusters. And the rest, well, that's nothing, or dark matter. I personally think it's dark matter, unless there were pockets of nothing in the universe before the Big Bang. Okay, before we dive into more theory and go crazy, can we just appreciate how simple this all is? I mean, yeah, the math is... but the concept. Our whole universe came about because some parts were just a bit denser than others, and one day it went boom. And yet, it makes intuitive sense in a weird way. So, what's in these galaxies? There it is! Our home! This is the Milky Way. Let's take a gander. Behold, the Milky Way. Ain't she a beaut? So, where exactly are we? How about we start from the inside and work our way out? Ah, my eyes! That, my friend, is a quasar. What's a quasar? Well, this is a supermassive black hole at the center of our galaxy. Spoiler alert, most galaxies tend to have one. It makes sense. A black hole is created by collapsed matter. Since so much stardust and who knows what was all crammed here when our galaxy was formed, it's no wonder a black hole like this came out of it. A quasar is a jet of superheated plasma that fires away from a black hole at the speed of light. Wait a second. I thought nothing could escape a black hole. That's right. However, this matter never entered the black hole. The black hole's gravity creates an accretion disk that orbits it. And whoo boy, it spins fast. The friction of all of these elements leads to some of it slingshotting off into space in a giant plasma beam. Pretty dope. And look, there are even stars orbiting this black hole due to its gravity. In fact, it looks like the whole galaxy is spinning around this point. Now, no, the supermassive black hole is not that strong. But when our galaxy was being formed, it's possible that this behemoth started its spin, and here we are today. As we venture outwards, we encounter more kinds of stars, like neutron stars, the failed black holes of the galaxy, with magnetic fields so powerful they could fry Earth in an instant. And look, here we have a wild rogue planet. No one knows where it's from, and no one knows where it's going, but it's on its own for now. Watch out for black holes, by the way. Most of them aren't as flashy as the one at the center of our galaxy. Ooh, that's a nebula, the remains of a supernova that creates new stars like a nursery in our galaxy, as matter gets pulled together through gravity. Our whole galaxy is like a spiraled neighborhood. It's ridiculously complex with a simple design to it. It's beautiful. Ah, yes, a nice star. And wait, guys, it's our solar system! We all know it. Our home, our celestial neighborhood. Want to hear a fun fact? That is not our solar system in the slightest! You have been lied to yet again by the slightly deranged and usually inaccurate textbooks of the crappy science fiction education that is the American public school system. Okay, that was very dramatic, but I digress, because this genuinely makes me angry just to look at.
Robert, it's pissing me off.
There we go. That feels better already. Now, how exactly does this all work? Remember earlier when I said some pockets of the universe were denser than others, leading to the formation of galaxies? Our solar system is like a mini version of that. Billions of years ago, our solar system was just a bunch of gas that gravity pulled together until bada bing bada boom, star. Seeing as there was a bunch of debris left over, gravity again would pull the masses together until planets began to form that orbited this young star, which itself was flying through the galaxy, which itself was flying through space. But Back to the solar system, some planets gained so much mass, they formed utterly massive gas giants. These are our outer planets, and if you think about it, it makes sense. When the sun was created, its combustion sent gases out as well as rocks, but those rocks and debris didn't go as far. Gravity magic, and boom, terrestrial planets. Oh, yeah, and there's one that's kinda a freak, or a few. And, yeah, I guess gravity's not magic either. If you zoom all the way out, you'll find the Oort cloud, a massive, cloud of debris orbiting the solar system. Now, wait a second, this kind of looks like our galaxy, which kind of looks like our universe. This entire complex system, all of it, is modeled by simple physics rules that govern our universe. Mass big, gravity small, orbit big gravity. Small mass, orbit big mass. Some pockets are more empty than others, but held together by something? It's beautiful to see the universe, galaxy, and solar system modeled by the same rules that govern life here on Earth. It doesn't change, and it's a simplistic marvel. Speaking of, here we are at last. This is Earth, the first and so far only home of the human race. It's also the same place where humans discovered the laws that govern literally everything, especially this guy, the fig bar himself, Isaac Newton. Side note, yeah, Einstein, Heisenberg, Aristotle, Feynman, etc. did kind of play a huge role in what we know today as the craziness that is physics, but right now we're sticking to Earth, which means we're sticking to the classics. So Newton discovered that there was this force, you may have heard of it, that pulls objects to the ground, and he was like, okay. Then one day he probably got really annoyed and kicked a wall really hard. Ow! Okay. Then he kicked another box and it crashed into the wall. Okay. And I don't know, he probably watched an apple roll off his desk before he could stop it. Oh man, my apple. Now, if the totally accurate version of Newton's life I just told you rings any bells, you know about Newton's laws of classical physics. And the funny thing is, they seem so intuitive. If you try to hit a wall, the energy you put into that wall comes right back at your foot. Ow! If a box is sitting on the ground, it won't move, well, unless you kick it. Then it ain't staying on the ground. And if you don't stop that apple, it will keep going. Hang on, what if we were to punch through the wall? How much force do we need to do that? Well, okay, say you have a massive foot. No, I mean this kind of mass. If we kick it at the same speed, there's more power. Aha! So force is proportional to mass. Not quite, but we're close. If you kick too slow, that mass ain't doing crap. But add acceleration and you get the force you need. This equation is the basis for all the fundamental rules of physics everywhere. You can turn it into so many different equations and expressions, but at the end of the day, everything on Earth, the solar system, the universe, follows these principles. It's also why I shouldn't ram my car into a wall or swan dive off a cliff. Side tangent. Get it? Because Newton invented calculus. Do you think force was given the name Newton's by Newton or after? I don't know. Knowing him, I feel like Newton did that himself. Alright, we have one more step to take. However, I'm about to break your brain a bit. Ironically, where we're going next is where the step I said throughout this video gets turned on its head and spun around. Can you step in here for a second? So, funny story, all the rules of physics we talked about so far are gone. Well, kind of. Here's the thing, you are now a subatomic particle, and gravity is so weak, it doesn't affect you. Remember, gravity is based on mass, and these things, well, they barely have any. Okay, so what the heck is going on? Well, let's start with the atom. Ah, look at it. Wait, that's really nice. Too nice. Yep, guess what? You've been lied to. Again. This is a poster from your 8th grade science classroom. In reality, atoms look more like this. But let's stick to this model just for simplicity. Okay, I'm not conforming, just moving on. This is the nucleus of an atom, and it's orbited by electrons. The nucleus is made up of protons, which have a positive charge, and neutrons, which have a neutral charge. Electrons, as you may have guessed, have a negative charge. Now, does this model look familiar? Wait a second. Yep. The atom follows the structure of the rest of the universe. It's so fascinating how the universe, down to a literal atom, has the same structure. Even when the rules of physics affect them in different ways, across all sizes, you get the same result. By the way, we can get smaller. These are quarks, bosons, leptons. Oh yeah, did you know light is a particle? Well, actually, maybe. Here's the thing about this universe inside our own. Many of these particles are so small, light passes around them, meaning we literally can't see them. But we can track their effects and, of course, theorize. So what holds these particles, or waves, depending who you ask, together in their own little existence? Luckily for us, there's only 3 fundamental forces here. The strong force that holds particles together, the weak force that allows the decay of particles, and electromagnetism, which, as you could guess, deals with electric charges and, well, magnetism. And that brings us to one of the most fascinating ideas in all of quantum physics, Heisenberg's uncertainty principle. It basically says the more precisely you know about one property of a particle, based on whatever of these rules, like its position, for example, the less you actually know about another thing, like how fast it's going or its momentum. It's not just about our tools being limited, it's a fundamental rule of physics itself. On the smallest scales, reality becomes so blurry, so probabilistic in its dance, where certainty just doesn't exist. It's wild how deep quantum physics goes. The equations get so unbelievably complex over little particles we literally can't see, and yet underneath it all of that math, there's a kind of simple beauty. Tiny particles following strange, almost poetic, or seemingly bullcrap, mind-melting rules that somehow build up everything from stars to your frickin' coffee cup. Stop drinking that frickin' coffee, okay? Coffee's nasty. And here's where it gets even crazier. The big world, the one ruled by Einstein's laws of motion, the physics of planets, galaxies, and gravity, doesn't play nice with the quantum world. The two sets of laws don't line up, but if physicists could somehow marry the physics of the very small and the very large, we might finally reach what's called a theory of everything, a single framework that makes up all of reality. But I'm getting sidetracked. If you want to watch that, I have a whole video on the theory of everything. One more thing before we leave this environment. So, you know friction? Like, if I were to rub my hand against a wall, like, really, and press down really hard, it, like, you know, does the friction thing, whatever. These particles are really far apart. Like, if I size them up, oh my gosh. That begs the question, though, how does friction freaking happen? If you want a video on that, y'all let me know, because, like, good lord. Don't you just love physics? Anyways, I'm going on a rant. So, yeah, after all of that, what have we learned? Well, that I still don't understand physics, but now I don't understand it better. I mean, come on, we just went from galaxies the size of trillions of suns to particles that can't decide whether they even exist, and somehow it all connects. That's like discovering your left sock and the Andromeda Galaxy are freaking cousins. That metaphor made no sense. What? And honestly, that's what makes physics so weirdly simple. It's both the most complicated and the most straightforward and intuitive thing you could think of. Everything we see, every atom, planet, awkward family reunion, all boils down to a handful of elegant principles that somehow hold this entire universe together. And yet, we've barely scratched the surface. I didn't even talk about Schrödinger, that absolute menace who looked at a cat and went, yeah, it's both alive and dead. Deal with it. Like, sir, there were rules, and you broke them. And don't even get me started on entering relativity and Einstein. I mean, if you want a video on Einstein and Schrödinger, I guess I could make one. I will absolutely be making one. But that's the beauty of it. Every time we think we've got the universe figured out, some physicist in a slightly wrinkled lab coat shows up and goes, actually. And suddenly, everything makes sense and no sense at all. So, while physics might seem like an endless headache of math, paradoxes, and cats with questionable mortality statuses, underneath it all, there's a stunningly human simplicity. Our attempt to understand everything, from Newton's falling apple to quantum uncertainty, from galaxies colliding to quarks just, vibing? Physics is the perfect blend of chaos and order, of complexity wrapped in simplicity. Hello, good peoples. It is Saturday now? But we're gonna pretend it's Thursday. Happy Thanksgiving, everybody! Look, I never claimed to be timely. I just wanted to let you know I am thankful for all of you. Consider subscribing, consider liking, consider sharing. And yeah, it's 4 a.m. now. I'm gonna go to bed.